machine learning. So let's first talk about what we'll cover in this course. So we'll first talk about introduction to machine learning, what machine learning is and what it does. We're going to look at the tools for machine learning, what we're going to use to make our machine learning models, and all the other things we need to do to make an effective use of machine learning. Then we're going to look at real-world problems we can solve using machine learning. So let's first look at a problem that can be solved with machine learning and not with classical programming. So here we have a picture of two dogs and two cats. Let's say that we wanted to make an application that counts the number of dogs in the picture and the number of cats. If we wanted to do this with classical programming, we would have to define the features that is on a dog and a cat. So to define a dog, we'll have to calculate the number of ears, the eyes, the nose, and all the features it has, as well as the cats, the ears, the eyes, the nose. So all of these parameters can change depending on what type of angle you take the picture from. So our 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 applications only work on one side of the image. So in classical programming, it would be practically impossible to make an application that does this. But using machine learning algorithms, we can actually make them very simple and very fast. So let's look at more problems we can solve using machine learning. So we can solve self-driving cars. We can make self-driving cars with machine learning like Tesla or any other EV manufacturers. We can make robotics or robots to do everyday tasks like cleaning, taking the dishes out, and doing chores. We can also use it to do language processing, so process languages like Siri and Alexa, and vision processing like like the previous problem where we try to identify either if it is a dog or a cat. Now we are going to install Jupyter Notebook. So Jupyter Notebook, we are going to use this as our editor for our machine learning programs. So if you've never used Jupyter Notebook before, it is a very good next generation notebook interface for machine learning. So here you can see we do in-depth linear regression. So you can do a lot of cool stuff with machine learning with Jupyter Notebook. And if you don't have a machine, if you don't want to use Jupyter Notebook, you can also use Colab. So Colab is an online version of Jupyter Notebook by Google. So you can also use that. But here for this tutorial, we are going to use Jupyter Notebook. So to use Jupyter Notebook, we are going to use Anaconda. So Anaconda is a distribution. So if you go to their website, anaconda.com, so anaconda.com contains everything related to data science you can imagine. So here, data science for the world, a better today. Then you just look at for your installer, get additional installers. So depending on your system, you're going to get a specific version. Today I'm going to be using Windows. I've already installed this on my system. So this is what the Anaconda Navigator looks like. So here you can see everything is appearing right here. So, and we're going to use Jupyter Notebook. Now, we're not going to use any of these tools. We're just going to use Jupyter Notebook. Now, you're also going to have to at some point define your environments. We're going to do that in the next tutorials. But with Anaconda, it basically comes with NumPy, scikit-learn, pandas, all of those things you're going to need. So let's go to our terminal. So in our terminal, you're going to define your own place where you're going to do your tutorial. You're going to do a folder. Here I'm going to have it in my desktop in a folder called Python tutorials, and inside of that folder we're going to have a machine learning folder where we're actually going to do our testing. And currently it's empty. So if I do ls, it's currently empty. So let's just run Jupyter Notebook. Jupyter Notebook. So Python Jupyter Notebook, Jupyter Notebook. And now when I say enter, it's going to start up the Jupyter Notebook. Now Jupyter Notebook, you're going to run it on your browser. So it's not a standalone application, but it's going to run. You're going to get the editor interface in your browser. So it's going to give you a link, and it's saying Jupyter Notebook on my brother. Currently, I have nothing in my folder, so I'm going to create a new file. I'm going to say, okay, the Python. So it's going to be the kernel already present on your system, Python 3. So this is the folder interface where everything, the terminals that are running, the notebooks that are running, and the clusters. We're not going to use this interface. So here we have. Now this is the interface. Let's rename it to home hello world. Every programming tutorial should start with hello world. So to test it out, we're just going to say print hello world, and I'm going to do Control Enter to run it. So it has printed it. So this is basically us setting up our environment. So now, after you have installed Jupyter, first Anaconda, then Jupyter, then you're going to make a new file. Then after that, you're going to test it, and if it works, in the next tutorial, we're going to start importing our data and cleaning our data. See you next time. So next, we're going to import our data. So first, go to kaggle.com. So if you don't know what kaggle.com is, it is a website that deals everything with machine learning, from the data sets and code. It also has competitions, and you can learn data science. So for this, we are going to get a data set from the website called Video Game Sales. So if you don't have an account already, just make an account and sign in. You can sign up with Google, Yahoo, or a specific email and password, but whatever you want, you can sign in. You can even use Facebook. So after you've signed in, you go to this search bar right here and just say video game sales. Then you're going to see a whole lot of data sets. Just tap view all. For now, it gives me 72 results. I want you to pick one that has a little bit of red icon. So this one right here, 6 years ago by Gregory Smith. So yeah, Gregory Smith. Here we have the video game sales. For now, we're only just going to work with the version number 1. Here we have version number 2. Just right here in the Data Explorer, version 2, tap it, then just go to version 1. So this version 1, here you can see some information about the data sets. This data set contains a list of video games with sales greater than 100 copies. It's generated by a scrape of vgcharts.com. So here you can see the fields that are included: rank, name, platform, year, genre, publisher, North America sales, European Union sales, Japan sales, and other sales and global sales. So here you can see in the Data Explorer that some information about it. So it has 11 columns, compact, and some column information. So here is some information about the columns, like the rank, the genre, the publisher. Then finally, you're just going to download it. So after you downloaded it, it's going to show, you're going to put it right next to your Jupyter Notebook file, dataset.zip. You're going to extract it, then you're going to get the vgsales.csv inside of it, and you're just going to put it right here next to the Hello World file. So after that, let's just go back to our terminal. So here, let's just import pandas, import pandas as PD. So what we're doing now is just importing it and renaming it. So importing pandas, then renaming it to PD, so we don't have to do pandas dot for every single method we're going to use. After that, let's just import it, our file PD read underscore CSV vgsales.csv. Then this is going to return us a pandas data frame object, which is basically like an Excel spreadsheet. So if you just do Control Enter or just run here, it's going to process it. So it's trying to It might take a little, depending on your PC's performance, it might take time to read the CSV and output it. But so it's in the process of extracting the data. So let's wait a little bit. So in the meantime, read CSV. Since we put the file close to right here, right here, our terminal can access the file. So if you come back, here you can see the CSV files. So here we have 16,000, so 60,598 rows by 12 columns. So the reason here we have 12 columns is because pandas right here adds another column as an index. So it's just something pandas does by itself. For us, it doesn't really matter. The next thing we're going to do, let's look at a description of the shape. So df.shape, df.shape. Okay, I've got to save the data frame object as df. Then let's do this again. So df.shape. Here it is 16,598 by 12. So technically this is 16,598 arrays of arrays. So what it basically means, every single row is treated as an array. So here we have an array that has 16,598 arrays inside it with 12 elements each. So here you can see that here we have two rows to get the output. So output 4, and if you didn't have this, here we have output 5. So you can use this to do all of your, so instead of just having all of your code in one single block, you could just spread it out and see the results. So one of the great things about Jupyter is it allows you to see the output of your code instantaneously. But if you try to do that with Visual Code or in the terminal, it would be very clunky because you have to run the application again every single time in the terminal or in your editor. So nothing, let's just describe our data. df.describe. So describing our data means it's going to give us some basic information, like in the ranks, it counts the number of ranks we have, 60,598. The number of EU sales, all of this is how many we have. And the rank, the mean, so mean is just your average. So the mean of a rank doesn't make any sense. So the EU sales, the average is 0.14, Japan sales, other sales, global sales. And standard deviation is how much it varies. For rank, it doesn't mean anything, but for EU sales, Japanese sales, it makes a difference. Now the minimum, so the minimum is 0, so the minimum 0, and the maximum is 29. So it depends. So 29 for this, it kind of should mean billion, but if it does not, it does not matter anyway. So let's look at our data. So for rank 1, we have Wii Sports. On Wii, release date of 2006, genre sports. Publisher Nintendo, North American sales for 1.49. So I don't know if it's billions or in millions. So it may not be available. Now, you can see here it goes in order. So just like this. And the last one is know-how. The first one is Wii Sports because it is very, very common game. Now let's look at our values. So the input, the instance values. So here we can see it described as an array. So it is an array. First, it has one array. Then inside of that array, we have another array, which actually is the row. So this is basically a one. This is a two-dimensional array. This is a two-dimensional array with 60,598 with 12 columns. So 16,598 by 12 matrix, two-dimensional matrix. So this basically is our tutorial on importing the data. We can also see that we kind of have some unnamed data. If we look at the describe, if we look at our describe, here you can see that some of it, here we have unnamed 11. So in the next one, we're going to see if we can just remove it, or if not, we'll just use another data set. So next, I'm going to see you in the next tutorial. So today we're going to look at very common Jupyter Notebook shortcuts that allow us to basically make our lives easier. So if you just go to help and you just look at keyboard shortcuts, if you can just you do it in the help section, like help, then keyboard shortcuts, or you could just do it in the command mode, help. So here we have two modes, the command mode and the edit mode. So let's first define what the command mode and edit mode is. So in this block, you can see that here we have green, and if I actually tap inside of it, I have green. So if I just tap escape, it turns into blue. So here currently we're in the command mode. If it's green, then we're in the edit mode. In the edit mode, you can edit what's inside the block. In the command mode, you can't edit it. So first we have to be in the command mode, then we just tap H, then we can see the keyboard shortcuts. So in the keyboard shortcuts, the first and most foremost is the escape key, which allows us to turn into the command mode in the first place. Then we have find and replace, and all of these ones. So one of the most important things is you're going to have to do insert cells or make new cells very quickly. So to insert cells above your current block, you're just going to do A, and you're going to do B for below. So if you try to do this, currently I want to do A above, then B, here again E, and if I go up, then below again, you can do it. You can also do X to delete, and then delete. Other shortcuts include copy and paste, shift paste below, paste cells below. And in the edit mode, we have some other ones, like one of the most important ones is you're going to do it quickly is to do the run button. So what I mean is inside of here, if I just do here, df, if I want to run this without shortcuts, if I want to run this cell, I just have to tap run. But with the shortcut of Control Enter, it will instantly turn me into command mode and then run the cell. Then I can instantly do this. So let's go back, then do it again. Then we see a description. You can also do it more and more. So you're going to very quickly adapt to these shortcuts as you use more and more of them, and is something that you basically get over practice with time. Hello. In the next series of lectures, we're going to make an actual machine learning project. So let's say that you have an online music store, like Spotify, Apple Music, iTunes, or any other online music platform. When you get a new users on board on your platform, you're generally going to give them recommendations on what type of songs to read. So to give these recommendations, you're going to use a machine learning algorithm to match or to evaluate the tastes and preferences of your users. So for this machine learning model, we are going to be given what the users prefer, what they already want, and their age and sex. So when a new user signs up, he's going to give us his age and sex. So depending on his age and sex, we're going to give him a new music type of genre to recommend to him. So we're going to listen to get his preferences, one preference he already has, his age and his sex, then we're going to recommend him a song or genre to listen to. So what are the steps required to make a machine learning model? First of all, we have to import and clean our data. So we discussed on how to get our data. When a new user signs up, he's going to give us his age and sex and preference of music he likes. Then we're going to clean that data if there are null values or unfit values recorded in the data. We're going to split our data into training and testing data sets. Then we're going to make our model with a specific type of algorithm. We're going to train it on the training data sets. We're going to make predictions on our new model, then evaluate its performance against the testing data sets and improve it. So we're going to improve it whether by changing the model altogether or just changing a specific hyperparameter. So down in the CSV file below, I've already have a small data sets of manually made entries of age, gender, and genre of music village. So here, user one is at age 20, is a gender of 0, 1. So 1 is for male, 0 is for female. So he has he's a male of age 20 and he likes hip hop. Second user is age 23 and likes hip hop. Third user age 25 likes hip hop. 26 jazz. 29 jazz. 30 male jazz. 31 to 37 classical. 20 dance. 25 dance, and uses the data. So let's first go to our folder. So here in my folder, I have two files: my Hello World I file and my music.csv file. So you just have to get your Jupyter notebook up and running, then get back to your browser. And here we have our files. Then we're going to import our data. So for this step, we're just going to look at how to import our data. Import and clean our data. Now we're going to delete the previous stores, and then we're going to start. So we're going to import pandas SPD as usual, because this time we're just going to call it music data. Music data is equal to pd.read csv slash music.csv. Then let's just look at our music data. Music data. So if we enter this, we're going to see our music data. So it's first loading up. I think it's very slow because it's just starting up. But once our application started up, it's going to be very fast. So it's reading the CSV file and outputting it to the console. So here it's the same. It matches exactly with what we have. So this is the first step of importing our data. We're going to get the next step we're going to get into the next step in the next tutorial. See you then. In this next part of the tutorial, we're going to get into the next step of creating our machine learning model, which is cleaning our data. So cleaning our data means getting rid of duplicate values, null values, and generally useless data. So in this data set, there actually is no duplicating value or useless data. So we're actually going to split it into two parts. So the reason we're going to split this data set into two parts is because we're going to need an input features and prediction values. So input data set and output data sets. So given an age and a gender, we're going to predict the genre. So age and gender are the input values, and the prediction or output values are the genres. So music data. So for this, we're going to make two data sets, X and Y. X is the inputs, Y is the outputs. So to make this, let's first drop the genre column to get our input data sets. So there's actually a method called drop. If we look at the values or the methods for the drop, so if you tap Shift Tab, you're going to get information about the method. So here we have columns none. So we're going to do columns. We're going to define the column we're going to drop. So columns and an array genre. We're going to drop genre. And we're going to, so this method doesn't actually change the original data frame. It's just going to return us a new data frame with the column specified deleted. So we're going to do X, capital X, then X. Let's look at it. So here we have our data set with the genre dropped. Now let's also do our genre. So to do that, we're just going to do music data with genre. Genre Y. Okay. Y small y, and let's do y. So hip hop. So these are our prediction values. These are the values we're going to try to predict. So we're going to use the x as input features and y as the prediction values. So let's get to the next part of this. In this part of the tutorial, we're going to make our model. So for this tutorial, we're actually going to make a decision tree classifier, or we're going to use a decision tree for our model. So to use the decision tree, you're going to first install scikit-learn, and I've already installed this on my system. So if you haven't already installed it, please install it. And scikit-learn is the most popular machine learning package in Python, and it already comes with the machine learning models pre-programmed, so we don't have to manually program it ourselves. So let's first import it from sklearn.tree, from sklearn.tree import decision tree classifier. So for this model, let's first try to make our model. So this is a class. The decision tree is a class. So let's first make an instance of our class. Model is equals to decision. Let's just copy it. Decision tree classifier, and then the instance of the class. Then you're going to give it the input and output data. So we're going to give it x and y. So model.fit, we're going to train it x and y. So let's first try to look at our prediction data, our actual data. To predict it, before predicting, let's first look at our data. Case this processing. So I've just started up my kernel since we done it from the last tutorial. So it's going to start up every single time. But after the kernel has started up, it's going to be a lot faster. So let's first talk about what this decision tree does. So decision tree is a binary system where we make decisions based on yes or no systems, or like a decision tree, like a tree. So starting from the top, we're going to say yes, if this yes, if this no, then we're going to go down from the top to the bottom, depending on the type of conditions, saying yes or no. So it's like a tree of decisions. So that's why it's called the decision tree. So we're going to use sklearn for this, and it's going to take it. Okay, let's just, in the meantime, let's just code it. Okay, x is not defined. Okay, so this is capital X. Okay, so in our data, you can see that we have no male for the gender male from 20 to 25, they like hip hop, but we don't have an instance of 21, an age 21 male. So we're going to try to predict the preference or the genre preference of an age 21 male. So age 21, you can see there's an age 21, but from 20 to 25 is hip hop. And for the females, we're going to do a 22-year-old female. So 20 to 25, they like dance, but we can't see there's a 20, there's not a, an age 22 female in the data. So to actually predict it, you're going to make model.predict. So you're going to give it a two-dimensional array, and this is the outer array, and the inner array, you're going to give it the input data. So we're going to give it age 21 for a male, and for the second prediction, we're going to do age 22 for a female. So you can see that there's no data, age 22, there's no age 22 female, and there's no age 21 male. So we're going to store that in our predictions. Prediction. Then let's look at our predictions. Predictions. See, here's hip hop and here's dance. So most of the time, your models might not be as very simple as this, depending on what type of data and what type of problem you are working with. You might not choose a decision tree to a decision tree classifier. You might choose another type of machine learning model, and depending on the circumstances, it might be appropriate. So in the next tutorial, we're going to look at how to actually measure our error. Since this data might not be accurate, we have to see how much error our model has, because depending on what type of model we use to train it, it might have errors, and we have to check all of those. So in the next tutorial, we're going to look at that. Today, in this part of our tutorial, we are going to look at model accuracy. First, let's split our data into two parts, our testing and prediction. So we are basically going to make it into training and testing data sets. So normally you should use 70 to 80% of your data for training and the other remaining 20 to 30% for testing. So for this, we are going to use 80% testing, 80% training, and 20% testing. So to basically do that, you are first going to import another package. So we're going to use a package from scikit-learn called train test split. So from sklearn dot model selection, model underscore selection, import train underscore split. So to split our data, let's go to the bottom and then let's train split our x and y value. So our inputs and outputs. Then we're going to define our test size, which should be about 0.2, so 20%. And this gives us a tuple with 4 elements. We're going to define these as x train underscore train, comma, test y, and you get the gist of it. Y testing. So here we've defined it in such a way as we're going to get a couple. Let's make a few spaces. So to basically train it, instead of using our entire data to fit the model or to train the model, we're just going to use the training set. So train and then train. So with this, we are testing our model. We are going to model to predict with not with these inputs, but we're going to use testing ones. Test. So now these are predictions. If we run it, okay, not text size, but text size. Okay, so this for our specific X test, these are our answers. But now to check the predictions, we're going to use we're going to test it. So to test it, we're going to import a package called from sklearn dot metrics import accuracy score. We do an accuracy score. We're going to use the predictions. So let's define our score. So score would be equal to accuracy, our accuracy score with our testing y sets, and we're going to try to match it up with our predictions. Predictions, okay, let's run it. And at the bottom, let's have score. We run it, so where our score ranges from 0 to 1. So 0 is it is completely wrong, 1 it is completely right, and for this case it is completely right. But if you run it again and again, it's going to give you different outputs. So it gave us 0.75. So this is because it takes the testing data sets randomly. So the model might not have learned enough to do it. Now, if we change our testing data sets, so we use 20% for testing, but instead, if we use like some like number like 80%, it's going to be like our model accuracy is 13% and 40%, 33%. So it changes depending how much data you use. So let's put it back at 8. Okay. Okay. I think okay, and no code. Okay. 33%. Oh, okay. Okay. I think I didn't save it. Uh, Testing. Okay, our test size is 80%. Let's bring it down to 20%. Now it's 100, 175, 50%, 100. So the more data you use for testing, the more data you use for training, the better. And sometimes for making models, like if you want to make a model that checks what type of animal is in an image, you're going to need a lot of data set, a lot of data, like millions and billions of pictures to test it. So depending on what type of problem and what type of criteria you are trying to solve your problem with, the amount of data and the amount of the split between your training and testing data sets might be different. And those are the specifics. So next we are going to look at model persistency. So today we're going to talk about model persistence. So here you can see this is our original code. And in the original code, we first train the model before we can actually do the predictions. Now, this may work for a small piece of data like our data set, which only has 20 rows of data. But for an actual machine learning project where we use millions and billions of columns and rows to actually train our model, it is not feasible to run it to train our model every single time we are trying to predict some piece of data. So that's why websites and other applications usually just save the model or dump the model into a file. Then whenever they need to predict it, they just choose the model they've already trained and to predict it. So here you can see that we're fitting it. So let's first import it from problem import dump and load. Okay, so now we're going to dump it. So model dot uh, dump. We're going to dump it into. We're going to dump our model to a file called music recommender dot. So you're going to do the name of the model and the name of the file you want to save it in. So I've dumped it. So here in the file we can see this is my model. So now let's actually try loading it. So we're going to this one. We're going to comment it out, then comment this out as well. Then let's say load model is equal to load, and then music recommender dot problem. Okay, and let's see our predictions. Predictions. So hip hop. So this is how we persist our model. So let's get into the final and last lecture. See you in the next video. So now we're going to actually visualize our model. So in the first part, we said that the decision tree is the most simplest method of machine learning model. So we're actually going to show this and how simple it is. So first from sklearn import tree, then we're just going to do just write it out, then I'll explain it later. We dot export this program this model out file. music calendar dot then featured feature names is age and gender class names are, well, it's going to be y dot unique. So we're going to get unique ones. Then let's just sort it out. Sorted. And we need all labels. Label should be all. Rounded would be true. And then filled would be true. So what we're doing is we're exporting our tree, our decision tree, into a file called music.recommender.dot. So dot is a graph visualization language. So let's just run it. And this running is outputted. So here we have it is output. So what I'm now going to do is actually just first I'm going to get my window. I'm just going to get my window. So you need to have Visual Studio installed for this. Then you're going to install an extension called .graph.visualize. Here I have this one. So you're just going to insert it from here to here. So after you're going to just insert it in. So here we have it. So this is our graph. So you're just going to hold Control Shift and V to visualize it. Okay. So this is going to give you a preview. So this is our dot language, and this is going to be our, and this is our recommendations. This is a visualization of our decision tree. So let's first talk about what it means. So if it is true, it is false. So let's say its age is less than 30.5. So it is less than 30, equal to or less than 30 is true. Then we go this way. If it is false, then EC Genie is 0, and the class they need is classical music. So class is the outputs, the Y's, and the reason here we have Y dot unique is because in the columns in the genre the names are repeated. So we're going to do unique, and we're just going to sort it out in order. So we're going to sort it out in the alphabetical order. So depending on that, we just classical. If it is true, then we're going to say if the age is less than or equal to 20.5, it is true or it is false. So if not, if it is not, it's just acoustic. So here it talks about gender 0.5 and 0.5. So I didn't do it as gender. Sorry, my mistake. I'll write it again, and it should give me another preview, and preview again. So now it's correct. Gender is less than 0.5. Less than 0.5 means a girl, and if it is, then it goes this way or this way. If it is not, less than 0.5, hip hop. If hip hop or jazz, then if the girl is less than 25, she likes dance. If it is not, she likes acoustic. So let's talk about what the parameters actually mean. So here filled means these boxes have colors. You can see all of them have colors. Rounded means it has rounded edges, the boxes. Labels means these are all label, age, genie, samples, these all have labels. The class names are the outputs, the final results, the predictions we have. So classical, acoustic, the genre are if our genres. The feature names is the inputs we are going to classify with, so age and gender. And finally, the output file is where we actually save it. So that concludes our machine learning course, and thank you for your time.